The farthest, far-off fake item in the universe, NASA's Explorer-1 test, is purportedly radiating valuable information back to Earth. We can gauge the universe, regardless of whether we have any idea what it is. The renowned NASA space apparatus, Explorer-1, which was sent off over a long time ago, has now returned a signal that has stunned mainstream researchers. Explorer-1 has found something so huge that it has changed the trajectory of its central mission and is now heading back toward Earth after traveling more than 14 billion miles. Come on this infinite excursion with us. Explorer-1 made a stunning discovery 7 minutes ago when it began its journey back to Earth. But what exactly could this revelation be? Could it be a grandiose deviation, proof of alien life, or something even more extraordinary? We will uncover these surprising discoveries in this compelling examination. As Explorer-1 just made a staggering revelation that caused it to turn back toward Earth, we should delve into the historical backdrop of the Explorer twin tests, two of the most astounding space apparatuses ever launched. They might never have left Earth if certain cosmic events hadn't aligned. The four largest planets in our solar system aligned in a rare occurrence. These planets were slowly adjusting exactly 50 years ago, a phenomenon last observed in the mid-19th century under the administration of Thomas Jefferson. Initially, this strange planetary alignment was mostly ignored. In 1965, Gary Flandreau, a PhD student in flight at the California Institute of Technology, was the first to understand its significance. At NASA's Jet Propulsion Laboratory in Pasadena, California, during the early stages of space exploration, Flandreau was tasked with determining the most practical approach to launching a space probe to Jupiter or further afield to Saturn, Uranus, or Neptune. Using only a pencil, he charted the orbital paths of these massive planets and discovered something astonishing. All four of these giant planets would align in such a way that a single mission could visit each one. This rare planetary arrangement allowed a spaceship to use gravitational slingshots to shorten its travel time. Flandreau's calculations showed that this alignment could reduce the 30-year journey from Earth to Neptune to just 12 years. However, there was a catch. This planetary alignment only happens once every 175 years. To capitalize on this unique opportunity, a spacecraft would need to be launched by the mid-1970s. NASA created two spacecraft to undertake this mission. Seizing this once-in-a-lifetime opportunity, Explorer-1 and Explorer-2 were launched on an incredible mission to study the outer planets of our solar system. The launch of the Explorer twin tests on September 5, 1977, was nothing short of remarkable. Thanks to the planetary alignment and Gary Flandreau's groundbreaking calculations, Explorer-1 was launched into space at Cape Canaveral, Florida, using a powerful Titan III-E rocket. Explorer-2 followed suit on August 20, 1977, just 15 days later. Explorer-1 embarked on its journey through the vast universe shortly after. The primary goal of the mission was to investigate the solar system's enormous gas giants, such as Jupiter and Saturn, as well as their moons. However, these boundary-breaking explorers exceeded all expectations. They traveled farther and longer than any other spacecraft in history, setting records and pushing the boundaries of exploration. Throughout their incredible journey, the explorers ventured into interstellar space, traveling over 12 billion miles from Earth. The astounding discoveries they made continue to astonish scientists. Over 40 years ago, the Explorer twin tests achieved remarkable feats. For example, the close examination of Jupiter and Saturn's moons revealed surprising activity. Previously thought to be desolate and cratered, these moons were instead found to be hives of activity. In 1986, Explorer-2 made history by becoming the first of the twins to pass Uranus. 3 years later, it achieved what no previous spacecraft had done, flying past Neptune. NASA employed clever techniques to ensure the spacecraft remained operational, turning off non-essential systems like heaters to conserve energy. The goal was to keep the spacecraft functioning at least until 2013. This strategy paid off, as the explorers continued to make incredible findings from deep space. For example, only 546 days after its launch, in March 1979, Explorer-1 arrived at Jupiter. That same year, in July, Explorer-2 followed on a slightly different trajectory. The spacecraft's cameras captured over 33,000 images of Jupiter and its moons, revealing new and fascinating information. One of Jupiter's moons, Europa, was discovered to contain an estimated 60 miles or more of cracks in its icy crust. Using a gravitational slingshot, the spacecraft left the Jupiter system with a final speed of 35,700 miles per hour, propelling it into interstellar space. The explorers diverged in their paths as they reached Saturn. After flying by Titan, a moon shrouded in orange haze, and passing through Saturn's magnificent rings, Explorer 1 left the planetary plane and traveled north. Explorer 2 went on to make groundbreaking discoveries, such as finding 10 new moons of Uranus and detecting the fastest winds ever recorded on any planet in the solar system, up to 1,000 miles per hour. The explorers' journeys officially ended when their cameras were turned off. However, NASA extended their missions, renaming them the Explorer Interstellar Mission, and aimed to push them beyond the heliosphere. On Valentine's Day in 1990, at the urging of astronomer Carl Sagan, Explorer 1 captured its final images, including the iconic pale blue dot photo showing Earth as a tiny speck from 3.8 billion miles away. In 2012, Explorer 1 became the first spacecraft to cross the heliosphere, marking a historic milestone. The data it transmitted from interstellar space continues to reshape our understanding of the universe. Explorer 1's crossing of the heliosphere in August 2012 was a monumental achievement. The heliosphere, a vast bubble of charged particles created by the Sun, marks the boundary between our solar system and interstellar space. This crossing provided scientists with the first direct measurements of the environment beyond the Sun's influence. The following year, in 2013, a groundbreaking paper detailing Explorer 1's discoveries was published in the journal Science. This marked the official confirmation that the spacecraft had entered interstellar space. Scientists observed a notable increase in electron density, measured by Explorer 1's plasma wave instrument, during a solar eruption between April 9 and May 22, 2013. These vibrations, caused by the solar eruption, confirmed that Explorer 1 was traveling through a region with higher particle density compared to the heliosphere. While this may seem counterintuitive, interstellar space is filled with particles from exploded stars, making it denser than the near vacuum of the solar wind-dominated heliosphere. By analyzing this data, researchers concluded that Explorer 1 officially exited the heliosphere on August 25, 2012. This finding was supported not only by the increase in electron density, but also by the dramatic drop in solar particles detected by the spacecraft. The success of Explorer 1's interstellar journey was a source of immense pride for the mission team. Despite being launched over 4 decades earlier with limited technology by today's standards, the spacecraft continued to provide groundbreaking insights into the universe. Explorer 2 followed a similar path and eventually crossed the heliosphere as well. Together, these spacecraft have journeyed farther than any human-made object in history, venturing into the uncharted territory of interstellar space. In their final stages, the explorers are expected to continue transmitting data until their power sources are depleted. As of now, their nuclear-powered batteries are gradually losing energy. It is anticipated that communication with the spacecraft will cease sometime in the late 2020s or early 2030s. However, even after their instruments go silent, the explorers will continue their voyage through the galaxy. These silent ambassadors of humanity, carrying their golden records, time capsules of Earth's culture, sounds, and greetings, will travel through interstellar space for billions of years, long after humanity is gone. The legacy of Explorer 1 and Explorer 2 is not just about their discoveries. It is about the enduring curiosity and ingenuity of humankind. These spacecraft symbolize our desire to explore the unknown and to seek answers to questions we have yet to ask. As they continue their journey beyond the stars, they remind us of the vastness of the universe and our small yet significant place within it. Their incredible odyssey inspires future generations of scientists, engineers, and dreamers to push the boundaries of what is possible, ensuring that the spirit of exploration remains alive. The explorer's journey through interstellar space not only represents a technical triumph, but also serves as a profound reminder of humanity's aspirations to explore beyond our limits. As they drift further into the vastness of the galaxy, the data they have transmitted has already revolutionized our understanding of both the solar system and the environment beyond it. One of the most significant aspects of their mission is the golden records they carry. Phonograph records encoded with sounds and images depicting the diversity of life and culture on Earth. Curated by a team led by Carl Sagan, the records include greetings in 55 languages, music from various cultures and eras, and natural sounds such as birdsong, thunder, and the heartbeat of a human. The golden records are humanity's message to the cosmos, a symbolic gesture of goodwill to any extraterrestrial intelligence that might one day encounter the spacecraft. Although the chances of the records being found are astronomically small, the gesture itself speaks volumes about humanity's desire to connect with the universe. As the explorers move deeper into interstellar space, scientists are left to wonder what new environments they might encounter. While the data they've collected has already shed light on the composition and structure of interstellar space, there is still much to learn about this mysterious region. One of the most exciting discoveries made by the explorers is the evidence of cosmic rays and charged particles behaving differently in interstellar space compared to the heliosphere. These findings provide crucial insights into how our solar system interacts with the broader galaxy, influencing theories about how stars and planets form and evolve. Looking to the future, the explorers' unprecedented mission has laid the groundwork for subsequent interstellar missions. Scientists and engineers are already designing spacecraft that could travel even farther and faster, equipped with more advanced instruments capable of exploring distant stars and exoplanets. The lessons learned from the explorers, extended lifespans, and resourceful energy management will guide the development of these future missions. These upcoming spacecraft might also be designed with more robust communication systems to maintain contact across even greater distances, potentially allowing humanity to send probes to neighboring star systems within the next century. Though the explorers are now traveling in silence, their legacy endures. They serve as a testament to the power of human ingenuity and the unyielding curiosity that drives us to seek answers about the universe. Long after they lose power, they will continue their cosmic journey, carrying their precious messages from Earth. In billions of years, as the explorers traverse the galaxy, they may eventually come close to other star systems. In the incredibly unlikely event that an intelligent civilization discovers them, the golden records will provide a snapshot of what life on Earth was like in the late 20th century, a whisper from a distant past, floating among the stars. The Explorer missions remind us that even though we are small in the grand scale of the cosmos, our efforts to explore and understand the universe make us part of something far greater. As we push further into the unknown, the explorers will always stand as pioneers of interstellar exploration, a legacy of humanity's first steps into the infinite.